For our project, we had the driving question of how can we as engineers use natural materials to clean bodies of water. To start us off,
What is a wetland?
So a wetland is a unique ecosystem that is mainly flooded with water. It's mainly soil, gravel, and sand. And a wetland also brings a massive diversity into the neighboring environment.
What deliverables did you create for this project, and how do they relate to the driving question?
So the deliverables that we built are the CAD model and the physical model. The CAD model represents the structure. It shows how the water is at the bottom, then it's the rocks, then it's the sand, then it's the soil. That's right. And then we have a physical model which shows you how the wetland performs. One of my experiments, I put the oil in the water to see like if the water would come out clear, and it did. And the wetland also shows how it can reduce flooding by not letting the box fill up with water.
for this project, we also had to create a 3D CAD, or a computer-aided design.
Hi, my name is Elijah Nunn, and this is my CAD of a wetland in a box.
How does your CAD resemble a wetland?
The different layers represent the 3 layers of sediment. The whole represents an aquifer.
What techniques did you use when constructing your wetland?
The techniques I used when making it were shell, hull, and fillet. I used shell to hollow out the container, hull to make the aquifer, and fillet to round the edges of the container.
How does it relate to the overall theme of the project?
The wetland in a box represents a constructed wetland, which is a man-made wetland designed to filter polluted water and reduce flooding.
Now I will present my Flipgrid, which covers every topic in detail. Welcome everyone, this is my presentation on my constructed wetland. The main topic of the project was wetlands and how beneficial they are to the environment. In class, we learned that a lot of the wetlands have been cleared out for living space and industrial use. This is a really big issue because wetlands are very important to the environment. They contain lots of species of animals and plants. They can filter water, and they can even prevent flooding. For the project, we were also given a scenario to work from. My contaminant was salt, and my scenario was saltwater intrusion. The goal of the project was to design a wetland that could possibly protect these groundwater sources as well as freshwater sources from saltwater intrusion. The reason we chose wetlands is because they are very good at naturally filtering water at a low cost. And as mentioned earlier, they are also very good for the environment. So why not build one? My hypothesis was that if we were able to create a wetland that could easily be installed in most places around the city, then we could get more financial support as well as just support from government officials. This idea could be a possible solution, but it will take a lot of collaboration from scientists and engineers to perfect. Combining the environmental knowledge of scientists and the architectural skills of engineers will allow us to create the most environmentally friendly and effective wetland possible. Our research included looking for places locally in which a wetland could be most effective. I found that there was a lot of wasted space under parking lots and roads that could be used for wetlands. In addition, the spots were in places where nobody would be affected by the wetland, which to me was very important because it would encourage community support. This is a picture of a potential place where the wetland could be built. The first step in the engineering design process was to create a 3-dimensional CAD of our wetland. The CAD was a scaled-down, full-size wetland so that the viewer could get a better idea of the placement of the wetland. The gray platform above the wetland would be the parking spaces. Right below, you can see the 2 tubes, which would be the straw aquifers. And at the very bottom, you can see that there are 3 different layers. The last one would represent the sand layer, the second one the gravel, and the first the topsoil. After finishing the CAD model, I proceeded to build a real-life scaled-down model. The video playing is a time-lapse of the build. The materials used were the plastic box, sand, gravel, topsoil, cotton balls, a paper straw, a pipette, blue food coloring, a quart container, and water. Before starting the build of the wetland, I decided to only build a portion of the wetland for better representation. The first step in building the wetland in the box was to place the sand at the very bottom of the box, towards one side only. We wanted to make sure that there was a slope, so that the layers could be more visible. Then we had to place the gravel evenly on top of the placed sand. At this point, I decided to make a small line to mark the end of the topsoil layer. After we added the topsoil, we made sure it was even on top of the gravel and that the slope was clearly visible from the side view of the box. Afterwards, we put the cotton balls to create the filter between the water and the land that would help to retain the salt from intruding. At this point I realized that I had forgotten to put the straws in before the topsoil, so I had to dig a little so that I could insert both straws. After finishing the build, it was finally time to start inserting the water. First we put the water into the straw aquifers. After the water reached the top, we added the water to the box. The material that I added that was not in the supplies was the blue food color. That way, I could better represent the salt, and the cotton balls could represent the filter, which would retain the salt. In conclusion, the wetland in a box wasn't the most successful. The straw aquifers didn't hold up well, and I couldn't really see if the water was to the very top. Even with those flaws, this idea has a lot of potential. Using more advanced materials and engineering designs, we could perfect the wetland to make it more efficient. We can see from the cotton balls that the filtering did work in our simulation. Being in the classroom might have helped a little bit so that we could get physical help from the teacher. Thank you for checking out my presentation. We also had to write a letter to a politician.
Hi, my name is Naya Champion, and today I'll be talking to you about my project. My project is building a wetland. I wrote a letter to a politician. My politician was Sheila Jackson Lee, and I wrote to her because I feel as if she would be able to get the letter first and, solve the problem. So I feel, and my wetland is by Energy Institute High School in the Bayou. I feel that's a good place to have it because it floods there and it has really bad filtration and really bad water that, we can't drink or use, and it's bad for animals, and there's really no animals in there or no type of living in there because it's so bad. So I feel the most intriguing part of my letter was when I stated that it would save us money and that it would overall benefit the environment and help us in the long run.
In conclusion,
what would you have done differently?
So one thing I would have done different is I would have used real contaminated water with oil instead of using food colors, so I could have got the real thing.
What were your biggest takeaways from this project?
What I took away from this was I learned that wetlands are a vital, they're a key resource with almost no drawbacks. I learned how they work, and I learned all the advantages they bring to the environment.